Welcome, my dear students. I am Mr. Muhammad Mustafa, math teacher. In this video, we are going to cover some ideas in Lesson 1, Algebra, for Secondary 2. Lesson 1, talking about the functions. We are going to talk about and focus about finding the domain of some functions. In this question, he asked you find the domain of these functions. And these functions are multiple definition functions. We notice that the domain separated into many intervals. To find the whole domain of the function at all, we find the separated domains. When we talk about the first example, f of x equals -2 at x greater than 2, 3 at x smaller than 2. To find the domain of the whole function, we find d1 domain of the first and domain of the second, then find the whole domain union of two domains. Let's start about the first. When we talk about the first, d1 x greater than 2 means all real numbers greater than 2 from 2 to infinity. 2 here open and infinity always open. D2 domain of the second rule, x smaller than 2, it means that all real numbers smaller than 2 from negative 8 from negative infinity to 2 to here open. To find the domain of the whole function, we find d1 union d2. d1 union d2 from negative infinity to 2 and from infinity to from negative infinity to 2 and from 2 to infinity. We have all real numbers except number 2. The domain here are except 2. We can find the domain using the number line. If we draw a number line, and here we have number as 2. The first interval from 2 to infinity, 2 open and infinity open. The second from negative infinity to 2, we have all of these number. We have all the number line except number 2. If you can't find the domain mentally, you can use the number line. When we talk about the second example, d1, we find d1 and also d2. Domain of the first, x smaller than 3 from negative infinity to 3 and 3 here open. d2, x greater than or equal 3 equals 3. That means that we have 3 and all real numbers after 3. 3 open, 3 belongs the domain, 3 and infinity. To find the domain of the function, we find d1 union d2. We can find it mentally from negative infinity to 3 up to from negative infinity to 3, and from 3 to infinity we have all real numbers. Domain is R. When we talk about exercise number 3, we find d1 and also d2. d1 f of x equals x at x greater than or equal 0 and smaller than or equal 1. The second rule, 2 minus x, when x greater than 1, smaller than or equal 2. Here the domain limited, has a start and has also end. d1 from 0, x between 0 and 1, from 0 to 1, x greater than or equal 0, 0 belongs the domain and 1 also belongs domain. d2x between 1 and 2, X greater than 1, that means that 1 doesn't belong to the domain, and 2 belong to the domain. To find the domain of the function, we find D1 union D2. 0 and 1, we can use the number line. We use the number line to represent the two intervals. Number line. We have 0 and 1. 0, 1, 2. Here 0, 1, 2. From 0 and 1, 0 closed, 1 closed. From 1 open and 2 closed. We have all real numbers from 0 to 2. The closed cover the open one. We have all real numbers from 0 to 2. Then the domain equals 0 closed, 0 closed and 2 also closed. And this exercise, the domain of the function separated into 3 parts. Each part has a specific rule. The first, f of x, 3x at x belongs the first interval, 6 at x belongs 2 and 4, x plus 2 at x belongs 4 and 6. We can find and we can calculate the domain here mentally without steps. If you can't, you can use the number line to find D1, D2, D3, and use the number line to union all of these intervals. D1 from 0 and 2, then from 2 and 4, then from 4 and 6. We notice that we have the real numbers from 0 to 6. Domain equals from 0 to 6. 0 here closed and 6 also closed. We notice that number 2 here, 2 belongs the domain and doesn't belong the domain. Here 2 belong, and 4 doesn't belong the domain, and 4 belongs the domain. It's no problem. To check your answer, you can use the number line. We choose number line at the first. Number line. We have 0, 2, 4, 6. Here 0, 0, 2, 4, and we have 6. Let's represent the 3 intervals from 0 and 2 closed, 0 and 2 closed interval. The second interval, 2 open, 4 open. The third, 4 closed and 6 also closed. Here from 0 to 2 and also from 4 to 6, we have all real numbers from 0 to 6. Let's talk about the second, f of x, 3x. Here, all real numbers from 0 to 6. Domain equals 0 to 6. Look about here 2 here open and here also open, but 4 doesn't belong to the domain here and belongs the domain. We notice that 2 doesn't belong to the domain in this interval and also in this interval. That means that 2 doesn't belong to the domain. Then the domain of the function from 0 to 6, all of real numbers from 0 to 6 except number 2. And you can use the number line, the union, the 3 intervals to check your answer. When we talk about the last f of x, 3x, the 3 parts from 0 to 2, from 2 to 4, 4 to 6, also the domain equals 0 closed, and 6 also closed. Look about 2 here open, and here open. That means that 2 outside the domain, and also 4 doesn't belong here and doesn't belong here. That means that domain of the function from 0 to 6 except 2 and 4. 2 and 4 outside the domain of the function. To find the domain of this function, we find d1 x smaller than 3, d1 from negative infinity to 3 and 3 open, d2 from 3 numbers from 3 to from 3 to 8 and 3 closed and 8 also closed, d3 x greater than 8, all real numbers after 8 from 8 open to infinity. To find the domain of the exercise, we find the union of d1, d2, and d3 from negative infinity to 3, from 3 to 8, then from 8 to infinity. If we union the three intervals, you can find and you can deduce that the domain equals from negative infinity to positive infinity. That means that the domain is R. Then he asked you to find F2, F3, F0, and F8. F2, find the value of the function at x equals 2. 2 belongs the first interval because here we have all real numbers except 2. We substitute by 2 in the first rule. F2, put x equal to negative 4 times 2 plus 3. Negative 8 plus 3 equals negative 5. What about the second? The second, F3. F3. 3 here, if the second rule x between 3 and 8 greater than or equal 3, we can substitute in the second rule by x equals 3. Negative x power 3, negative 3 power 3, negative 27. When we talk about the third, F3, F10, F10. 10 belongs to the third rule because 10 greater than 8. We substitute here by substitute by x equals 10. 3 times 10 power 2 plus 1. 3 times 100 equals هنا 300 plus 1 equals 301. The last, F8. 8, where 8 belongs to the second interval. We substitute here 8, substitute in the second rule by x equals 8. Negative x power 3, negative 8 power 3 equals negative 512. Represent graphically all of these functions. The first f function from this set to this interval and this rule of the function. Firstly, we know that the function has domain, and also codomain. Domain represented by elements of x, codomain elements of y, and also has the rule of the function. We can use the rule of the function to represent the function graphically, and we know that the domain, the range of the function subset from the codomain. To represent graphically the first function, we substitute here it is a domain, here the domain. This is domain, and this is codomain, and this is rule of the function. We substitute in the rule by x negative 3 once, and negative 1, negative 2, negative 1, negative 1, positive 1, and 2. Uh, put x equals negative 3, 2 times negative 3, negative 6 plus 3 equals negative 3. At x equal negative 1, 2 times negative 1, negative 2 plus 3 equals 1. At x equal 1, 2 plus 3, 5. At x equal 2, 4 plus 3 equals 7. We represent graphically negative 3 and 3. Negative 3 represent graphically these points, negative 3 up to negative 3 down to negative 3, negative 1 up to 1, 1 up to 5, 2 up to 7, 2 up to 7, and here the domain of the function are separated elements, negative 3, negative 1, 1, and 2. So we have the image of negative 3, negative 3, image of negative 1, image of 1, image of 2. Here we don't join. Here we doesn't join these points because we only have the image of 4 points. If the domain of the function is a set, we never match or we never join all of these points. The second function from 1 to 5, this is the domain of the function, and this is the codomain R. The rule of the function f of x, x plus 1. We find the domain of the start and domain of the end. We find the image of 1 and the image also of 5. We put x equal 1 and put x equal 5 and any other number between 1 and 5 to check our answer. For example, we put x equals 2. At x equal 1, 1 plus 1, 2, 5 plus 1, 6, 2 plus 1, 3. We represent graphically the function 1 from 1 up to 2, 1 up to 2, then 5 up to 6, then 2 up to 3. Here we notice that the rule of the function x power 1 plus 1, the function from the first degree. We name it a linear function. We represent the first degree function by a straight line or a part of it. Here we represent the first degree function by straight line, or ray, part of it ray, or line segment. If the domain R, we represent the first degree function by straight line. If the domain open interval, unlimited interval like x greater than 5, from 5 to infinity, it has a start and has no end, we represent by array. If the domain is limited from the start and the end, limited interval, like 1 and 3, we represent it by line segment. Here the domain of the function limited, we represent it by a line segment. We join the 3 points. Here we notice that the 3 points belong to one straight line. These 3 points are collinear. We match the 3 points. Stop. Here we represented the first function and the second, and also the second function. Function from R negative, from negative R to R, the domain of the here domain, and here codomain. We can express the domain by interval R negative from negative infinity till 0 open. we substitute by these values in the rule of the function, and from negative infinity to 0. Here we substitute by 0 by any number smaller than 0, negative 2, negative 3. Put x equals 0, 0 power 2 equals 0, negative 2 power 2, 4, negative 3 power 2 equals 9. And here we notice that 0 is open. Don't forget that 0 is open. 0 and 0, then negative 2 and 4, then negative 3 and 9. The rule of the function if x equals x power 2, it is second degree function represented by a curve. We don't use here ruler. We join the points by hand free. Join these points from these points. Here we must extend the curve a little after 9 to know that we have image of negative 2, 4, image of negative 3, 9, and also image of negative 4 and 16, negative 5, 25, negative 6, 36, and so on, because we have all the domain of the function, all of real numbers is smaller than 2. Here find the domain of all of these functions algebraically. F of x equals x plus 5 over x power 2 minus 9. To find the domain of fractional function, if the numerator and denominator are polynomial function, we find the domain using set. The domain equals R except set of zeros of denominator. If the domain, if the fractional function has numerator and denominator, and both of them polynomial functions, we use this rule: R minus set of zeros of denominator. So we search for the values that make the denominator equals 0. F of x, x plus 5 over x power 2 minus 9. We put x power 2 minus 9 equals 0. X power 2 equals 9. Taking the square root, x equal positive or negative 3. Then domain equals R except 3 and negative 3. The second, 9x plus 7 over 8. Here the domain of the function the denominator is constant. Then the domain equals R minus set of zeros. There is no zeros of denominator because the denominator is constant. The domain here is R. The third domain of the function, x plus 5 over 3x power 2 minus x minus 2. We put the denominator equals 0. Denominator x power 2, 3x power 2 minus x minus 2 equals 0. And we can factorize this trinomial to find values of x equals 0, 3x power 2, 3x times x, and 2 here, 2 times 1, 3x negative 3 positive, here 3x plus 2 equals 0, or x minus 1 equals 0. 3x equals negative 2, x equals negative 2 over 3, and here x equals 1. Then the set of zeros of denominator, negative 1 and negative 2 over 3. We can check our answer by calculator. Mode. We use the calculator to find the set of zeros by factorizing the trinomial 3x power 2 minus x minus 2. Mode equation 5 3 3 equals -1 equals -2 equals x1 equal 1, x1 equal 1 here, x1 equal 1, x1 equal 1, and x2 here, -2 over 3, -2 over 3. Then the domain of the function, domain equals r minus set of zeros of denominator r minus 1 and -2 over what? Over 3. Number 1, put denominator equals 0, 3x power 2 plus 15x equals 0. We are taking common factor, 3x common factor. X power 2 divided x equals x. 15 divided 3 equals 5 equals 0. Then x equals 0 or x equals -5. Then domain equals r except 0 and -5 because they are set of zeros of denominator. Number 2, x power 2 plus 9 equals 0. X power 2 equals -9. If we take the square root, here we don't have any squared quantity negative. Here set of zeros of denominator is phi. Then the domain of the function equals r minus phi. Oh, sorry, r difference phi. Domain of the second function is r. Number 3. Put number 3 first. Put denominator equals 0. Denominator equals 0. X power 3 plus 8 equals 0. That means that x power 3 equals -8. Take the cubic root. X equals cubic root -8. X equals -2. Then domain of the function is r difference -2. The last number 4. Number 4 is a fractional function. Root function. Root 3 minus x. The root of the function here, the index of the root is even. We put the function under the root 3 minus x greater than or equal 0. 3 minus x greater than or equal 0. We multiply by negative and replace x and 3. X minus 3 smaller than or equal 0. If we multiply by negative or divide by negative, we change the direction of the sign of inequality, greater than to smaller than and smaller than to greater than. Here x smaller than or equal 3. That means that all of real numbers is smaller than or equal 3, from -infinity to 3, and 3 here is closed. F of x number 1, f of x equal square root x minus 4. We put x minus 4 greater than or equal 0, x greater than or equal 4, from 4 closed to infinity open. Number 2, square root of x power 2 minus 16. The function under the square root if the index of the root is even. X power 2 minus 16 greater than or equal 0. X power 2 minus 16 greater than or equal 0. We can factorize it by difference two squares. X power 2 minus 16, x minus 4, and x plus 4. We find that 4 and negative 4 are set of zeros, are the two roots of the function. Here negative 4 and 4. Negative 4 and negative 4 and 4, we put a sign different, opposite to a. Here coefficient of x power 2 positive, we put here negative, and here positive. At x equals negative 4 and 4, the function equals 0. Here 0, and here 0. We want all real numbers. We need all real numbers that makes that x power 2 minus 16 greater than or equal 0. We need this interval, and also this interval. We need the 0, and also we need 0 at negative 4. Then domain all real numbers, domain equals or difference from negative 4 to 4, or difference from negative 4 to 4, from negative 4 to 4. This is a closed interval. This open interval, because the numbers after negative 4 and before 4, all of these values are negative. We need all of values that makes x power 2 minus 16 positive or 0. The domain are difference from negative 4 to 4, after negative 4 till before 4. Number 3, square root 4 minus x power 2. We put 4 minus x power 2 greater than or equal 0. We multiply by negative, and it change x power 2 and 4. X power 2 minus 4 smaller than or equal 0. Factorize difference two squares, and find the sign of the function. X power 2 minus 4, x minus 2, x plus 2. Negative 2 and 2 are two roots of the function. We distinguish the sign of the function. Here negative 2 and 2. At negative 2 and 2, 0, and here 0. Between negative 2 and 2, opposite to sign of x power 2. X power 2 here is negative. Here we put opposite to negative, positive, and here negative, and here negative. We want the values that makes 4 minus x power 2 positive, greater than or equal 0, positive or 0, positive or 0, where positive or 0 in this interval. Domain of the function from negative 2 and 2. We need negative 2 and 2, from negative 2 closed and 2 closed, because we need the values that make the function positive or 0 from negative 2 and 2, negative 2 closed and also 2 closed. f of x equals 8 over x root square root x minus 4. If the square root in denominator, we put the function under the root greater than 0 only, not equal 0. We put x minus 4 greater than 0 because we don't need 0 at denominator because division by 0 is meaningless. X minus 4 greater than 0, x greater than 4. That means that the domain from 4 open to infinity also open. Here also f of x 1 over root x power 2 minus 4x plus 4. We put the function under the root x power 2 minus 4x plus 4 greater than 0 because the square root in denominator. We notice that the function the trinomial x power 2 minus 4x plus 4 is a perfect square. If we factorize it, we can find two similar brackets, x power 2 x 4 2 times 2 because their sum equals 4. Here positive, the two brackets are similar like the middle term negative negative. We find that the trinomial has only one root. We can find the sign of the function here at x equals 2, the function equals 0, and here like the sign of x, coefficient of x power 2, coefficient of x power 2 positive. We put here positive and positive. We need also we need the values that makes x power 2 minus 4x plus 4 only positive. Then the domain of the function domain is all real numbers except 2 or difference 2 because at x equal to the function equal at x equal to this expression equals 0 and we don't need 0. Number 1, find the domain of the function f of x square root 3 minus x. The index here of the root is even. We put the function 3 minus x under the root greater than or equal 0. We multiply by negative and change x and 3. Here x minus 3. If we multiply by negative, we change the direction of the sign greater than or equal by negative than or equal, negative than or equal 0. X smaller than or equal 3. Then the domain of the function from negative infinity till 3, and 3 here closed because 3 belongs to the domain. Number 2, cubic root. If the index of the domain, index of the root is odd, here we find that the domain equals r because if you want to calculate the cubic root of any function under cubic root, if the function if the value under cubic root positive, we have value. Cubic root negative also we have value. Cubic root 0 we have value. So if the index is odd, we find the domain also all times equals r if the domain is a cubic root in numerator. Number 3, here we have inside root and outside root. We find the domain of the inside and also the domain of the outside root, then find the intersection of the two domains to find the whole domain of the function. D1, domain of the first of this, we put 4 minus x equals 0, 4 minus x greater than or equal 0, x minus 4 smaller than or equal 0, x smaller than or equal 4, d1 equals negative infinity and 4 here closed. To find d2 we put the function under domain greater than or equal the function under the root greater than or equal 0. square root 4 minus x minus 2 greater than or equal 0. We move negative 2 there by different sign. Square root 4 minus x greater than or equal 2. To cancel this root, we square the both sides. Power 2, 4 minus x greater than or equal 2 power 2, 4. Negative x greater than or equal, we move 4 there. 4 minus 4 equals 0, times by negative or divide by negative 1. X change the direction of the sign, greater than or equal, smaller than or equal 0. D2 equals negative infinity and 0 closed. Negative infinity and 0 closed. This is the first domain, D1, and this is D2. To find the domain of the function, we find their intersection. We can use the number line, negative infinity to negative infinity and 4, negative infinity and 0, here 0, and here 4, and from negative infinity to 4 closed, negative infinity to 0 also closed, their intersection at this interval. Then domain of the function equals from 0 closed to 4 also to 4 closed. Number 1, domain of the fractional function. We can find domain of numerator and domain of denominator. We can find d1 x plus 1, it's a polynomial function, d1 equals r. d2 d2 it is a cubic root, also equals r. Intersection d1 domain of the function. To find the domain, d1 intersection d2 difference set of zeros of denominator. d1 r intersection r equals r. Set of zeros of denominator, the denominator equals 0 at x equal 1. If we substitute x by 1 minus 1 0, then the domain r difference 1, because 1 is a set of zeros, or is zeros of denominator. The denominator equals 0 at x equals 1. The second, we find d1 and also d2. Domain of numerator equals r. Domain of denominator, the denominator is a root function, but here the index of the root is even. We put the function x minus 2, x minus 2 greater than or equal 0, x greater than or equal 2, from 2 closed to infinity open. This is first domain and this is second domain. Domain of the function equals d1 intersection d2 minus set of zeros of denominator. D1 intersection d2 to an infinity, intersection r equals to an infinity, different set of zeros of denominator. What is the denominator? To find set of zeros of denominator, here we put the denominator equals 0. Denominator equals 0, square root x minus 2 plus 1 equals 0. Square root x minus 2 equal negative 2. To cancel the square root, make power 2 for the two sides. Power 2 here, x minus 2, negative 1 power 2 equals 1. X equals 1 plus 2 equals 3. Then the denominator equals 0 at x equals 3. Domain from 2 to infinity, difference 3. Number 1, d1, this is fractional function. To find it, we said find d1 and also find d2, find their intersection, then intersection of their domain, different set of zeros of denominator. D1 x minus 3 greater than or equal 0, x greater than or equal 3 from 3 to infinity. D2 x minus 5 greater than or equal 0, x greater than or equal 5 from 5 to infinity. This is D1 and this is D2. Their intersection, 3 and 5, from 3 closed to infinity, from 5 closed to infinity. Their intersection at this interval from 5 to infinity. Domain equals 3 and 5, 3 and infinity, intersection 5 and infinity equals intersection at the interval 5 and infinity, minus or difference set of zeros of denominator. Here the denominator equals 0 at x equals 5, difference 5. Here we can we can make 5 here outside of the domain by writing it open. Then the domain of the function 5 open, 5 and infinity. Domain 5 open, infinity closed. 5 and infinity. When we talk about the second also, d1, if you calculate it, 3 and infinity. d2, if you calculate it, put 5 minus x greater than or equal 0, you can find the domain negative infinity and 5, and also 5 closed. To find the intersection, you have 5 and you have here 5, sorry, put here 3 and put here 5, from 3 closed to infinity, from negative infinity to 5, 5 closed, their intersection here, d1 intersection d2 at closed interval 3 and 5. Domain of this function d1 intersection d2, then different set of zeros of denominator. Here the denominator also equals 0 at x equal 5. Domain of the function equals 3 and 5, difference 5 equals 3 closed and 5 open.